Hello, my name is Sanjeev Tripathi. In this video, I will explain functional programming in Lambda expression in Java 8, and I will demonstrate how to write functional interface and how to write Lambda expression. To set up the context and save some time, I already written some Java code, so I will move to the IntelliJ IDEA. Here I have created two interfaces. One is calculate interface, another shape interface. Shape interface have one undefined method that is called area and it takes two input parameter. Calculate interface also have one undefined perform method and it takes just one parameter. Prior to Java 8, to provide dynamic behavior, we need to use anonymous class. Here I have provided two implementation for the shape interface. Here is the circle shape, and here I am writing one anonymous class and implementing the area method. It's taking two argument, double x and another also double, and its name is y. And it's just printing the area of circle. So here's a formula for implementing the area of circle. So this anonymous class is creating the area of a circle. Similarly, here I'm writing another anonymous class and it's implementing area method. This is area of a rectangle, x into y. And I'm assigning this to rectangle variable. Then I have written one method, calculate area, and it accepts the x and y double argument and it takes shape object. And here I'm calling the area method of the shape object. So here I'm providing dynamic behavior. Here dynamic binding happens at the runtime, and based on the object you passed, it could be rectangle object or it could be circle object, it calculates the area accordingly. So this is the where the dynamic binding happens at runtime, and we are implementing this dynamic binding by implementing two anonymous class. And here I am calling that calculate area method. In one I am passing circle, another I am passing rectangle, and here the x and y argument. Let's run this code. So here we see this is the area of circle and this is of area of the rectangle. So based on the object that we get here, it's a calculating area. So it's calculating area of a rectangle when we are passing rectangle, and when we are passing circle, we are getting area of a circle. The same dynamic behavior we can implement using Lambda expression. From Java 8 onward, Java has introduced functional programming. In functional programming, we can pass function as an argument of a method. I'm going to convert this anonymous class in a Lambda function. This is a function, so we don't need this signature, class signature. So I'm going to remove this one. And this function is not a method inside a class. This would be outside of the class. This function, Lambda function, would not be inside any class. So we don't need this public void. An interface have just only one abstract method, one undefined method. So we don't need the name of the method as well. And we can use this closing braces also for the class. We don't need this. And to represent this is a Lambda function, we need to put this minus greater than sign. This is a Lambda function corresponding to the abstract method that is defined under the shape interface. We can also remove the data type of the arguments, because the compiler can know the data type from the interface definition and the abstract methods argument types. So we don't need this data types. And this is called type inference. Compiler can know this from the abstract method itself. We can refine further, because there is only one line of the code inside the function. We can even remove this curly braces, closing and ending curly braces. So this is a concise and more readable Lambda function, and this we are passing here in a calculate area method. Now we can change the second anonymous class also in Lambda function. So for rectangle anonymous class, I'm going to remove the class signature. We can remove the public void also, and we don't need the name of the method because there's only one abstract method. We can remove the closing braces also for class, and compiler can know the data type from type inference, so we don't need the data type for input argument. We need to put a lambda function representation minus greater than sign, and this method have just only one statement, so we can remove this closing and starting curly braces for the method. So this function is a lambda expression for rectangle, and we are passing here in this method. Now I will run the code and it should provide the same result. So now we are getting area of circle is 616 and rectangle is 700. So we have created a two lambda function, two implementation of this shape interface. We are passing in these methods and they are getting executed here. So based on the type of lambda function, it's getting executed accordingly. So here we are providing dynamic behavior of the interface, shape interface, by implementing the lambda expression. Now I will take another example where abstract method takes just only one argument. So here is a calculate interface. It have perform abstract method, undefined method, and take just one argument. And I have two implementation for that interface. First one is calculating square, and second one is calculating cube of the number. And I have provided that implementation using anonymous class. This is an anonymous class for a square, and this is anonymous class for a cube. Now I'm going to convert this anonymous class to the more concise and readable lambda expression. I don't need this class signature, class definition here, so I can remove this, and I can remove the closing braces as well. We don't need a public void because this is not the method inside a class. This is outside the class, so we don't need this public void. We can remove this. We can remove the name of the method because there is only one abstract method here, and we need to provide symbol to represent this is a lambda expression. We can further refine because this method of implementing just only one statement. We can even remove the starting and ending curly braces for the method. So we can remove this, and we can remove the ending curly braces as well. We don't need data types because that can be determined from the interface and the abstract method arguments. So we don't need this. One more refinement we can do here compared to previous lambda expression definition. Here we were passing two argument, and in this we are just passing one argument. So we can even remove this parenthesis because there is only one argument, so we don't have to actually put in parenthesis. This is a lambda expression, concise and more readable for the calculate interface. Now we can move this anonymous implementation for cube also in lambda expression. So we don't need this class signature and class definition. We can remove this. We don't need a public void, so I'm going to remove that as well. We don't need the name of the method because that can be determined from the name of the abstract method inside interface, and that's only one. We don't need to pass data type of the argument. That can be determined from the definition of the interface itself. We don't have to put a parenthesis because there is only one argument. We need to put minus greater than sign to represent this is a lambda expression, and here again we have only one statement defined inside method, so we can remove this starting and ending curly braces as well. Okay, I forgot to remove this ending curly braces for class. We have to remove this also when we remove the class signature. So this is a lambda expression to calculate the cube of a number, and we can pass this here in the calculate number method, and it will call the perform method based on the implementation of lambda expression. So for cube it will calculate the cube, and for square it will calculate the square. So we can run this. So we are passing 4 here, so the square of the 4 is 2 of the 4 is 64, and that's what we are getting. So we are providing runtime dynamic binding using lambda expression. Now we can, instead of creating a lambda expression and assigning to a variable, to an interface, we can directly pass this method argument. So we can take it out this thing and put it in place of here, and similarly rectangle also we can directly pass the lambda expression for a rectangle as well. We can remove this, we don't need this. Similarly for calculating a square, we can take this lambda expression and we can pass directly to the method, and here also we can pass the cube implementation of lambda expression, we can directly pass here. We don't need this. Now we can calculate area and the cube and square, and we are still getting the right results here. So you can see that how concise and more readable code is because we have used lambda expression. These lambda expression that we have written have a corresponding interface, calculate and shape right here, and these interface have an abstract method, and only one abstract method whose signature is matching with the signature of the lambda expression that is being implemented. So this area method have the same signature corresponding to signature that lambda expression is using. Same way, calculate interface have a perform abstract method and whose signature is matching with this and this lambda expression. These interfaces with one abstract method are called functional interfaces. So calculate and shape are the functional interface, and to tell the compiler that these interfaces should only have one unimplemented method, only one abstract method, we can annotate these interfaces with the functional interface annotation. So we can annotate these with the functional interface. So now we cannot write a signature of another unimplemented method. Same way we can annotate this also as a functional interface, and we are using these interfaces right here. Java already provide few inbuilt interfaces under the java.util function package. So Java have a consumer built-in functional interface. It takes a single input argument and returns no result. Same way it have BiConsumer. It takes 2 argument and returns no result. It have a int consumer. It takes a integer value and returns no result. Similarly, it have a double consumer. It takes a single double valued argument and returns no result. It also have a predicate and supplier. So predicate is a boolean valued function with one argument, and supplier represents supplier of the result. Like that, they have defined built-in functional interface. So we don't have to create a functional interface our own. We can use a built-in function also. We can change this definition here, calculate integer interface. Instead of this, we can use a consumer built-in functional interface. Where we have to change consumer, and the abstract method inside the consumer is accept. Similarly, here shape in functional interface takes two argument, so we can replace with the BiConsumer. Change here BiConsumer, and also method name is accept. So we are using here Java built-in functional interface. We can even delete these interface. We don't need this because Java has already provided a functional interface for common purpose usage. We don't need these two interfaces. We can run this code now and it should give the same result. Okay, it's giving same result. So this concludes the demo. Thanks for watching. Bye.